So here we are at the end of chapter 3, which means that the function we're working with, power, we're going to be given a y value and we're going to solve for x because that's what we did at the end of chapter 1 and the end of chapter 2. That's what we're going to do at the end of chapters 4 and 5 as well. Okay, so use regression to find a power equation to model the data. Okay, so the descent rate for the high energy sports emergency parachute is shown on the table. All right, so if your platform height is one of these, then you know what the rate of descent is measured in feet per second. And of course, these are the x's, these are the y's. Hey, this time, guess what, ladies and germs? I actually remembered to type it in before I started recording. Okay, so I've got all that there under stat, enter. And now I'll go stat, right arrow, and then I'll go up to power regression. Make sure it says L1 and L2. And there's my equation. So yeah, it's so nice using the calculator. Okay, so y equals, oh, and then of course I did not see how many decimal places we're gonna round this off. Where do I keep that? Oh, right here. Let's see, you guys, 3 decimal places. Got it. All right, so y equals 8.063 x raised to the 0.498 power. Okay, part A is done. Okay. And if you say it partay, you sound like you're from the 90s and you used to be cool. Okay, part B. Use your equation to predict the platform height necessary to have a 21 foot per second rate of descent. Round to the nearest 10. Okay. Well, a 21 foot per second, that's going to be, let's see, it's a feet per second. So that means it's a y value that they're giving us, this 21. And it's, it's about halfway between the 18 and the 24. So now, so our answer should be roughly halfway between the 5 and the 9. Now we're not doing, this is not a linear situation, so it's not going to be exactly halfway, but it should be, close. Okay. So, around, let's see, what's half of around 7 feet. Okay. And again, we could go off of the graph and, try and get a pretty good idea and say, all right, so 21 is this bold line right there. And that actually looks about exactly like 7, or well, it's maybe slightly above 7, but really close to 7. So it's always a good idea, when possible, to look at the data and get an idea of, okay, what do I expect my answer to be? And to look at the graph and say, what do I expect my answer to be? What's going on here? And then if you mess up on the calculation because you type something in the calculator wrong or whatever, you got a pretty good idea. And you've seen me do that. And when I've done that in these videos, it wasn't on purpose. That's just the way the cookie crumbles. And maybe I'm a bad person, but I'll tell you right now, I'm not really into those crumble cookies. Yeah, they just really don't do it for me. Okay. So 21 is a y value. So now let's go to here, get a little room to work. And whoops, that is not what I meant. Yeah, I'm trying to sell this car. Okay, so how do we do that? How do we do it? Well, we know 21 is a y value, so 21 is going to get plugged in for y, guaranteed. Okay. Now what do we do? Well, the next step is probably fairly obvious. We're going to divide by that number out front every time. So when you're working with a power function and you're solving for x, this is the process every time. Okay. So you're going to divide away by this number because that number is being multiplied by by x. Okay, so we got to divide it away. All right, so I'm just gonna do it on my calculator, on my handheld, not the computer one. So 21 divided by 8.063. And that gives me 2.604 equals x to the 0.498. Okay. Now at this point, we got to get just a little bit creative. All right. Now we're going to do something, you might very well have never done before. So we're saying, okay, I want to get x by itself. That's how it always is in equations. And x is being raised to the 0.498 power. These guys are not multiplied together. If they were multiplied together, we would just divide this away and easy peasy lemon squeezy. But that's not the case. This is an exponent on the x. So what we're going to do is we're going to raise the right side of the equation to the 1 divided by this power. Okay, this uses a rule of algebra that we didn't really worry about learning, that when you have a power raised to a power, you multiply them. Well, if you multiply something by 1 over itself, that always comes out to 1. So this is going to, so these guys are going to cancel and just give us x to the 1 power, which is just x. Well, if I do it to the right side, I got to do it to the left. Okay. And so, okay, so I go 2.604 raised to the 1 over 0.498. And I'm going to get x equals 6.836. And the units are feet. Again, I need to include my units or it doesn't make sense. Maybe I should double check that. Was it feet? I think so. Let's see, this button. Yeah, the x units were feet. So that's all you do to solve in a power equation every time when you're solving for x. When you're solving for y, well, that's easy. We saw that in the last video. But so if I had something like 4 equals 2 x to the 7th, okay, I would divide both sides by 2. And then I would say, oh, let's raise both sides to 1 over the exponent. 1 over the exponent. And then your answer would be 2 to the 1/7. And then you plug it in your calculator. And that's what you do every time on these power functions. Okay. And that's it.